experimenting with user-centric data storage for some time, and now we just recently launched the Ceramic network, which is essentially like a off-chain decentralized protocol for mutable data.
My name is David Vorick. I'm CEO and founder at SKYNET Labs. We build a decentralized cloud storage network. I got started in around 2013, so we've been building for a long time. We built an entire decentralized storage platform from scratch, and the general idea is that you pay host to hold data, kind of like Filecoin. Yeah, and we tend to focus on performance and on Byzantine fault tolerance.
My name's Alex. I work at C Labs in the applications team. Been there for like 18 months, and yeah, helped build out like the Celo story for storage, you know, whatever's there of it. And it's mainly like it was built out of necessity, basically to facilitate payments and move data off-chain. So yeah, excited to be here.
Great. You said user-centric storage. Would you mind taking a second to talk about what the goal of providing storage is in your platform, who it serves, what the applications are, and why you decided to build it?
All right, so yeah, although those are a lot of things wrapped into one, but I think, like, so we came out of, so me and my co-founders used to work at the Uport project, and so we're thinking a lot about how to manage a user identity. And one thing we realized when we created 3box was that an identity is not just verifications you get from different institutions and whatnot. It's more about the kind of data that you generate, and eventually that data kind of becomes your identity. So user-centric storage is really kind of we're building it kind of for users, but the people we provided to us like a service or like a protocol is application developers that can like start storing data with their users instead of on their database.
David, same question.
Yeah, so I would say that for most of the project, we've been very engineering centric. We want to build ultra reliable tools, and so most of our, I guess, 8 years now of development has been focused on performance, reliability, and kind of getting to the place where we can stand up to Amazon S3 and other centralized platforms. And then more recently, we've focused a lot more on web, and we're targeting mainly JavaScript developers, and that's just because that's where all of the energy is, and you can get this seamless cloud that's available on laptops, desktops, phones, like Nintendo Switches. And so we really want to bring this cloud that we've built to everyday users and give them just a complete experience where they always have their data on them, no matter what device they use.
And Alex?
I was too busy listening to these questions. What was the question?
Who are the users? What are the applications? And why did you decide to build that?
So, as I said, this was built out of necessity in the Celo network because we wanted to get data off-chain, like this on-chain memo property for every transaction. Celo was based on Geth, so this was really going to slow the network down. So we want basically every wallet in the ecosystem to provide a storage route for a user. And you know, the idea is if it's a little bit interoperable, you know, we can host anything on there and any wallet can show this data. Talking with like Web2 payments providers, they really just want like an endpoint they can hit to get information about a purchase. So that's what we basically tried to build for them.
So I think it's interesting that each of you identified a different core use case for the storage system you're building. We talked about users, data, memos, information about purchases. We talked about identity. We talked about Amazon S3 and the web. Would you mind talking a little bit about how your specific use cases informs the design of the storage system, what you built, what you prioritized, and why you made engineering decisions? And David, can we start with you?
Yeah, so the biggest thing on our mind is like we want to compete with the centralized web, and we don't want people to use our platform because it's decentralized, and decentralized is like quote unquote healthy. We want people to use it because it's more convenient and it's more powerful, and it's easier for entrepreneurs to innovate on because it has better features. And if you want to do that, I think that like users are used to web pages loading instantly, and you can't get away from, if you lose that, users are going to get frustrated, and they're not going to want to use your platform. And so for us, it's been just ultra important to make sure that things every time run super smoothly, that the platform's always performing. If there's like bugs in the code, the engineers know that it's their code and not our code. And distributed storage is an incredibly difficult problem engineering-wise. So it's taken us some time, but I think now we've got this really strong foundation, and I think we're kind of poised to start fighting back against like the YouTubes and the Twitches and the Facebooks of the world.
So you prioritize performance above everything else.
Yeah, if we don't know how to make something at scale as fast as Amazon, then we won't build it. So we don't add features until we are confident that we know how to get it running at scale as fast as Amazon can go.
Alex, same question. How has the application informed the engineering decisions that you've made along the way?
So we prioritized basically self-sovereignty and privacy from the very beginning. So our system is designed such that we have total receiver privacy. So every user owns their own storage root, and they can upload data to anyone. And the paths and data are encrypted or obfuscated in a way such that, you can ideally never leak any metadata about who that message or who that storage is intended for, basically.
So for things like purchase histories and other user information about transactions, you wanted privacy.
Exactly, yeah.
Same question.
Yeah, so I think there are two main kind of core principles that have led our decisions. One is kind of having a way of doing secure key revocation, which is like very important if you have like an identity system that you can like rotate keys. And we ended up with a solution for that that actually makes it impossible to trade identities. And the other part is having minimal pieces of data that you can work on, you can keep updating even if you're offline, but they also kind of work when you're online, so that each data object in our system has like its own micro ledger.
Interesting, very interesting. So I am very familiar with the Saya system and much less familiar with Ceramic and with Celo's storage system. I believe, and David, correct me if I'm wrong, Saya is designed to store data on untrusted hosts.
Yes, that's correct.
Is the same true of the Ceramic network?
Well, so right now you have to run your own node in order for it to be like completely trustless. If you run your own node, then I guess you can trust yourself.
So it's kind of a bring your own storage solution?
Right now, yeah, we want to add an incentive layer on top that allows you to pay the network to keep track of the state of your data streams, but that's currently not how it works.
Okay. So I might bring my own server or my own AWS account and store my information in it.
Yeah, right now it's kind of similar to IPFS in the way that most developers have some infrastructure provider that they're trusting to like pin the data streams.
Using centralized service providers that they trust and are willing to rely on.
Yeah, like either one or multiple.
Cool. Alex, how would you characterize Celo's storage system?
Yeah, very similar. So users, like power users, they can choose maybe something like a GitHub repository or an S3 bucket if they want to manage that manually. But for most users that use like a wallet, they trust that wallet and they trust the storage provider that the wallet uses.
Very interesting. So I'd like to open it up for a little more free-form discussion rather than me just interviewing each of you in turn over and over. Do any of you have somewhere that you want to start the conversation? We essentially have, I think, two relatively similar systems, and David is a bit of an outlier here, right?
I think so.
I'm just not familiar with the ceramic system, but like, how do you basically authenticate storage rights from like a browser or something like that?
So, like access control in ceramic, so an object in ceramic is called a stream, and basically it's like a public key that gates the access, and we use the W3C DID decentralized identifier standard to like represent an identity. But then it's kind of up to each node to choose which data streams that they pin.
If I'm requesting data from a particular public key, how do I get confidence that I'm receiving the most recent update for that public key?
So we use libpdp and like a gossip system to gossip about the updates. So it's, I mean, in a sense, that's kind of similar to what you have with a blockchain. You kind of ask the peers in your network, like, hey, what's the latest, block in the chain?
Okay, got it.
Is there any global ordering system for that, or is it just, query the peers?
So it's query the peers, but then like the event log for one particular streams is periodically anchored into the Ethereum mainnet.
Okay, so you at least get checkpoints of the current state is at least this sequence number.
Yeah.
Does that mean that every ceramic user is actually like making regular Ethereum transactions? Like how often do these transactions happen?
So a ceramic node can outsource that type of transactions to a third-party anchoring service, and which basically batches that into a Merkle tree and puts the root on chain.
And then is the anchoring service, do you depend on the anchoring service to make that data available? So you have like a Merkle root on the Ethereum blockchain, but then that doesn't do you any good unless you can break it down. So where do you get that data from?
Yeah, so the Merkle tree is like the first time that Merkle tree is created. Yeah, you need to fetch it from the anchor service, but then the Merkle tree itself is represented in IPLD, so I can store just the particular witness for my anchor of my stream. So I don't need to store the entire tree, but I used the vector commitment for my specific.
Gotcha.
So I feel like I just nerd sniped you. Would you mind taking a minute and trying to give a high-level description of what you were just talking about to the audience? I know, that's a very hard question.
Where did we start?
We started off talking about ACLs and how do you ensure that the state you retrieve is the latest version.
Yeah, so one of the problems that you have with decentralized storage is if you want mutable data, you have to know that the data you're receiving, so mutable data is like, let's say I have a blog, and every time I post a new blog post, I update my link to include my new blog post. So I get this kind of list of things that I've done, and so you have two challenges. The first is that if he's requesting my list of things, how does he know that those things belong to me? And since it's a pub key, he just looks for a signature, and as long as the thing is signed, he knows that I wrote the blog post and that it's my content. But a second, much more challenging problem is how does he know that he has all the blog posts? And so if he's talking to a distributed network, some node might return him something that's like 2 weeks out of date and doesn't have like 5 of my recent posts. And so the question is, my question to him was, if in that situation, how do we gain confidence that we have the most recent version of the data that's been published under the pub key? And so the answer was we we use IPFS and we anchor. I'll let you interrupt.
Oh, I think it was similar to IPFS, but maybe this is a good time for you.
Yeah, I mean,
to
so
take over.
If you think about like how a blockchain, how do you get the latest block of a blockchain, right? You have the same kind of problem. You need to like ask the network, hey, what's the latest block? and sure, you sync all the intermediate blocks as well, but you need to like find the latest block. So you have this peer-to-peer network where nodes communicate to each other, and you essentially ask all other peers that you know, like, hey, what's the latest block? And eventually, you'll get that from at least some node.
And is it fair to say that that's actually like a rather expensive process?
For queries, it's definitely expensive, yeah.
So it can be expensive to query many nodes to find out the latest state of David's blog.
Yeah, and the reason it's expensive, it's just because it's like a lot of bandwidth, especially if you have a node that queries like a lot of things. So we're actually right now looking into like how we can mitigate some of those.
Okay. So you might have a node that queries a lot of things and causes a denial of service on the network, or consumes more than its fair share of the network bandwidth.
Yeah, essentially.
I was going to ask, do you have any like cost structure in place to mitigate that denial of service? Or like how if a node is acting bad, how do you handle that denial of service?
I mean, I guess like in general in this type of like peer-to-peer gossip protocols, like if one node is sending a huge amount of messages, you can kind of start using some tit-for-tat system to like disconnect nodes that are very spammy. I think that's like a general approach that's like used by many protocols.
Yeah, so I might step in and talk a little bit about how SKYNET handles this problem, which is we make everything paid. And I think one of the big assumptions that we made in 2014, and when we were looking at like historic distributed systems, even like BitTorrent, what we found was that there's often a massive asymmetry between people who want to store data and want to like make requests, and then people who have resources to serve requests. And so oftentimes you get a couple of nodes with like tens or hundreds of terabytes, including like, you know, a gigabit connection and you know, great internet, that actually don't want to use the internet that much. And then you have like consumers on really thin connections that can't really participate in the peer-to-peer network very well, but also want to have a lot of activity. And so we solved this problem on Saya and on SKYNET by making every single request cost money. That also solves the denial of service issue, because if you're paying for every query, spam is not seen as spam by the rest of the network. It's seen as revenue opportunity.
So to kind of wrap up the conversation about spam, I want to circle back to Alex, who has been sitting here quiet for a few minutes. We have tit-for-tat nodes maintaining ledgers of what other nodes have queried and whether it's roughly in balance. We have everything costing money all the time. Does Celo have any specific denial of service or spam mitigations in place?
We basically just offload that to individual applications, which is a bit of a cop-out of an answer, I'm not going to lie. Because every application is, I mean, we have like reference implementations of the storage protocol. And for example, the Valora application uses like Google Cloud buckets to store data. So yeah, and like it's up to Valora basically to authenticate and rate limit requests to these buckets.
So it's, from the core protocol developer's perspective, it's someone else's problem.
Yeah, we punted that for sure.
Yeah, those are my favorite kind of problems. Okay, so we have just a couple minutes left on this panel. I'd love to open up for audience questions. I can't see very well, so yeah.
Maybe it's not really like hundreds of gigabytes of the actual web storage in their basements until eventually, like the government said, we shouldn't use all of the information up to being stored on maybe like one guy named Patel's servers. In our current paradigm, we see like we're trying to do distributed storage, and back then it would have seemed like crazy that we all have all these storage services like AWS and stuff like that. At what point do you think the blockchain world, even though it seems unrealistic that we might have like an AWS type storage situation in the future, do you really think it's unreasonable, or do you hope to aspire to like that kind of size project?
So I think the we can paraphrase the question is, over the last 30 years, we've seen this incredible growth from single machine storage to cloud storage that's ubiquitous and cheap. Are we going to see the same sort of transformation in distributed storage on-chain or close to blockchains? Is that about right? Cool. Does anyone have a strong opinion here?
Yeah, I mean, our goal is to just take over all storage, right? Like, why do we even have hard drives? It should just all be on the cloud. It should all be decentralized. And so we've definitely been shooting for like, 70% of all hard drives manufactured ever should just be the SKYNET network hard drives, and that's the end vision. And I do think that we're in that direction. We're very early, but give us 10 years.
That's very ambitious.
I think actually like there's many different types of way we want to store data. I think Saya and Filecoin and these other types of, or the other types of that type of protocols where it's you store data and like it's good for certain type of use cases, right? Where for example, I don't know if you could use Saya to like update data off chain or when you're offline, and keep like syncing between individual users and then like back that up to to your cloud. Like I think different types of applications will have like different requirements about like how the data is stored and how the data is represented. And you might need to tie into like different storage backend systems.
So it's not necessarily the quantity of data storage that matters that's going to see a revolution. It's how we access that data for a lot of applications.
I mean, I guess it could be both, right?
Alex, any opinions here?
I got nothing to add after that. I mean, to answer Gerald's question, yes.
Yes. Very good answer. Any other audience questions? One more.
So, you've just been appointed head of storage for AWS. What do you do?
Okay, so the question is, suppose you've just been appointed head of storage for Amazon Web Services. What do you do next?
We put it on the SKYNET network. No, Amazon does a lot of things, and yeah, I would just feel overwhelmed. I think I would sit down and just read documentation for 6 months straight.
Have a panic attack? Cool. Thanks so much to all the panelists. This has been really fun. I hope to see you all again soon.
Thank you, James.
Thanks.
Thank you. All right, so that was them. And for any of you, raise your hand if you understood 80% of what they just said. 1, 2. Raise your hand if you understood 50% of what they just said. We got 5 now. That was some galaxy brain stuff. And I'm happy that it exists and that we managed to make a space for that to foster and develop. We're going to give my esteemed